Hello everyone. I am Dr. Ganesh Kumar Thakur, Associate Professor, Department of Applied Sciences and Humanities, ABES Engineering College, Ghaziabad. Welcome you all. In continuation of prior lecture, successive differentiation, here I am going to introduce a very important theorem given by German philosopher and mathematician Leibniz, named as Leibniz theorem. The structure of this lecture is based upon these points. First, I will introduce the Leibniz theorem and the motivation behind Leibniz theorem, means why this theorem is important, statement and the concept behind the Leibniz theorem, how this theorem is going to implement to solve any problems. To solidify the concept of Leibniz theorem, we will practice some problems based on Leibniz theorem. Finally, limitations and conclusion will discussed. Leibniz theorem is not universal. There are certain limitations, and I am going to introduce those limitations also. So let's start. To introduce the concept of Leibniz theorem, let us take an example. Suppose we have to find out the 20th derivative of x square sine x. During the lecture of successive differentiation, we have gone through the concept behind how to find out the another derivative. Okay, suppose we have to find out the 20th derivative, then we have to differentiate it 20th time, or after certain times of differentiation we have to generalize the result. Let's see. Suppose we differentiate this result one time. Let's take y equal to x square sin x, and we have to find out 20th derivative of y. If we differentiate first time, pi 1, product rule, it is a product of two function of x square and sin x. Differentiation of x square is 2x sin x plus x square differentiation of cos x. Similarly, if we differentiate it again, y2 is equal to, I am going to differentiate this twice of differentiation of x sin x, product rule, differentiation of x is 1 sin x plus x, and differentiation of sin x is cos x, plus differentiation of this x square, differentiation of x square is 2x into cos x plus x square, differentiation of cos x is minus sin x. What we observe here is that it is not going to be a generalized, okay, and if we keep on differentiating, the calculation is going to be a cumbersome one. There must be some formula by which we can find out the 20th derivative at a ease. To our rescue, a very important theorem is given by a German mathematician Leibniz, which is popularly known as Leibniz theorem. This theorem provides you a process by which we can find out the nth derivative of product of two differentiable function of x. Okay, as mentioned here, Leibniz theorem is a concept that deals with the differentiation of product. Okay, this theorem provides a process by which you can find out the higher order derivative of a product of functions without having to repeatedly apply the product rule. This is the luxury of this rule. If you know the nth derivative of both the function independently, by applying the Leibniz theorem, we can find out the nth derivative of product of these two functions. It has a very vast application in the domain of mathematics, physics, engineering, economics, etc. Let's proceed. Statement of Leibniz theorem. It is a very, very important statement. I suggest you to remember this statement. Okay. It states that if u and v are two functions of x, obviously these two functions are differentiable, then the nth derivative of product of these two functions can be written as u and v. You may write it nc naught u and v plus nc1 un minus 1 v1 plus nc2 un minus 1 v2 plus so on ncr un minus r vr plus uvn. I hope you are well aware with this concept. ncr, it is equal to combination of r things taken from n, that is n factorial upon r n minus r factorial. To remember this formula is quite easy. I am very much sure you have gone through the concept of binomial theorem in your previous class, and it is nothing, it is just an expansion of u plus v to the power n as an binomial expansion. Simply, we can say that this theorem states that the nth derivative of the product of two functions u, v, n can be obtained by summing up the rth derivative of one function and the nth minus n minus rth derivative of other function along with combined binomial coefficient. Okay. So here I am going to solve the previous question by applying the Leibniz theorem. Means we have to find out the nth derivative as well as 20th derivative by applying Leibniz theorem. Okay. Let's see. Here given function is x square and sine x. Obviously, it is a product of two functions. Leibniz theorem states that if u, v are two functions of x, then its nth derivative is given by u n v plus n u n minus 1 v1 plus n into n minus 1 by 2 u n minus 2 v2 plus so on. Please don't confused by this notation. I have written is nc1 is equal to n, nc2 as n into n minus 1 by 2. Okay, you can check it out in your theorem. Statements contain these terms. I have put up the values of these notations. Okay, now we have to select which function is taken as u and v. Since we have to find out the nth derivative, we know if x square is differentiated 3 times or more than 3 times, it becomes 0. Okay, so let us take it v. V is taken as x square and u is taken as sine x. It's a standard result in successive differentiation. We have calculated its nth derivative. I hope you do remember, if y is sine ax, then its nth derivative is given by a to the power n sine ax plus n pi by 2. If you compare with this formula, un is written as 1 to the power n, that is 1 itself, sine x plus n pi by 2. If we observe the formula, here we see un minus 1, un minus 2. Simply we are going to find these derivatives. Un minus 1 is sine x plus n is replaced by n minus 1 pi by 2. Un minus 2 is equal to sine x plus n minus 2 pi by 2. We need v1. v1 is 1 times differentiation of v, it is 2x. v2, 2 times differentiation of v, it is 2. And v3, is equal to 0. So we don't require the higher derivatives because it starts to become 0. Just we have to find out the nth derivative of x square sine x. We put this value only. First term unv, we already calculated un, that is sine x plus n pi by 2 into v is x square plus n un minus 1 into v1 is 2x and un minus 1 is sine x plus n minus 1 pi by 2 plus we proceed further, it is n into n minus 1 upon 2 un minus 2, that is sine x plus n minus 2 pi by 2 into 2. Since the higher order derivatives are 0, it becomes 0. Okay, so that is our nth derivative of product of these two functions x square sine x. Okay, now we require to find out the 20th derivative. So simply by substituting n by 20, that is if we put n equal to 20, we get the required result. That is the beauty of Leibniz theorem. So it seems quite cumbersome to find out the nth derivative of product of two functions. By applying Leibniz theorem and suitably chosen u and v, we can easily find out the nth derivative of product of two functions of x. To make concept of Leibniz theorem more robust, here we are going to take another example. We have a differential equation x square y2 plus x y1 plus y equal to 0, where y is obviously a function of x. Then we have to differentiate this differential equation n times by using Leibniz theorem. Okay, let's see. Here, given equation is x square y2. It is going to differentiate it n times. Similarly, x y1 n times plus y n, and 0 is going to differentiate it n times. Okay, here x square is a function of x, y2, y is a function of x. So obviously its second order derivative and all the higher order derivative will certainly be function of x. Let's take v as x square and u as y2. I am going to implement Leibniz theorem for this particular term first only, and after that apply Leibniz on these two terms. Okay, let's see. V equal to x square. Leibniz theorem states that uvn equal to unv plus n un minus 1 v1 plus n minus 1 by 2 un minus 2 v2 plus so on uvn. Here u is this, u is y2, and v is x square. Un is y2, it will be added by n, that is yn plus 2, un minus 1, yn plus 1, un minus 2, yn. v1 is 2x, v2 is 2, v3 is 0. It means if we differentiate this function n times, it can be written as it is u n v, means I am going to use this, apply this formula u n v, that is yn plus 2 into yn plus 2 into v, that is x square plus n un minus 1 v1, that is yn plus 1 into v1 plus n minus 1 by 2 un minus 2, sorry, un minus 2 is yn, that is yn into v2 is 2. Higher order derivative of v is 0, so we terminate this process. That is our this. Similarly, we implement Leibniz theorem of this one. We take v as x, u is y1, un, that is yn plus 1, un minus 1, it is y1, v1 is 1, v2 is 0. If we apply Leibniz on this term, it is plus, it is un into v, un is yn plus 1 into v, v means x plus n, yn into v1 is 1, here our term is 0, not required to write it. No, y, it is a single function, it is going to be differentiated n times, it is written as yn is equal to 0. If we rearrange this term, this can be written as x square yn plus 2 plus this term and this term. If we take x, y, n plus 1 common, this can be written as 2n plus 1 x, y, n plus 1 plus this 2 cancelled out, yn is taken common, n square minus n plus n, that is n square yn is equal to 0. Next, we are going to take a very important examples that is going to be solved with the help of Leibniz theorem. Here the function is x to the power n log x, and we have to calculate its n plus 1th derivative, or given function is x to the power n log x, and we have to calculate its nth plus 1, that is n plus 1th derivative is what? Okay, let's proceed. Y is given to be x to the power n log x. We require to find n plus 1th derivative. It means first we differentiate 1 times. Our concept is based upon this thing. We differentiate first time and then apply Leibniz theorem. By using Leibniz theorem, n plus 1 times is differentiated. So consequently 1 times already been differentiated, and n times are going to be differentiated with the help of Leibniz. That is why n plus 1 derivative. Let's differentiate this. y1 is equal to product rule. Differentiation of x की power n is n x to the power n minus 1 into log x plus x to the power n. Differentiation of log x is 1 upon x. This implies if you multiply both sides by x, this can be written as xy1 is equal to n x to the power n log x plus x to the power n. Okay, and by the given question x to the power n log x is equal to y, so this value can be replaced by y, that is ny plus x to the power n. We have a relation this xy1 equal to ny plus xn. Let us assume its equation first. Differentiate first n times by using Leibniz theorem. Again, Leibniz theorem is UVN equal to UNV plus n UN minus 1 V1 plus n minus 1 by 2 UN minus 2 V2 plus so on UVN. We are going to apply the Leibniz theorem the term xy1. I hope you are well aware. I am going to write it directly. The value of this, if you apply the Leibniz theorem, is written as un, that is yn plus 1 into v, that is x plus n un minus 1 yn into v1 is 1 is equal to nyn plus n times differentiation of xn. If we differentiate n times xn, it is equal to n factorial, that is n factorial. This and this has been cancelled out. This implies yn plus 1 is equal to n factorial upon x. That's our answer. Here we have observed that by applying the Leibniz theorem to find out the nth derivative of product of two functions becomes quite easy. But there are certain limitations. As you know, this theorem cannot be applied directly for the function of more than 3 or 3 variables. Suppose you have to find out the nth derivative of 3 functions x square sine x into log x. We cannot directly apply the Leibniz theorem. It's one of the very, you may say, basic limitations of this function. Second one is, if n is large, as we know, we obtain the nth derivative by summing up the binomial coefficient rth derivative of first function and n minus rth derivative of second function. If n is large, the calculation is very, very complicated. Another limitation is that if the functions are not differentiable, means u and v, both functions, if any one of the functions are not differentiable, then this theorem cannot be applied there. It states clearly that if u and v are both differentiable, then we can find out the nth derivatives. So it limited the use of this theorem. However, there are certain restrictions. Still, this theorem is widely used in different domain of mathematics, physics, economics. We may say it's a powerful tool for calculating the nth derivative of two functions. Its application is well recognized. It's played a key role in development of differential calculus as well as integral calculus. While it has faced a lot of criticism and controversy over the year, the theorem remains an important and enduring contribution to the field of mathematical analysis. I hope you have understood the concept of Leibniz theorem, how this theorem is applied, what's its limitations. Thank you. Thanks a lot.